Good morning, Kani. Neha. Good morning to all the other students as well. I'm absolutely fine now. It will get better with time. Okay, let's begin with our class now. Right? Yesterday we had a discussion regarding what bonds are, and we discussed a few questions as well. Right? And I gave you one question as homework. Write down in the chat section how many of you have solved that particular question. Yes. How many of you solved the question which I gave you as the homework? Good morning, Vinny. Yes, how many of you solved the question? Very good. Very good. Okay. So this was the question that was given to you as homework. Question was the maximum number of hydrogen bonds that can form between hydrazine and water. Hydrazine's diagram or the molecular structure is given to you. It is N, H and H, and then you have N, H and H. Write down the answer for this particular question, everyone. Yes, what is the answer for this question? Mark down in the chat section. Everyone. It was a very, very simple and a very logical question, right? You just had to find out the number of the hydrogen bonds that can be formed between this hydrazine and water. Okay, so answer for this would be yes, option number 4. That is, 4 hydrogen bonds can be formed in here. Because you have 4 of the hydrogens available, so the O will be forming, like over here you have H. This is one water. This is another water. So one more, 1, 2. Then over here as well, one more water, and over here as well, one more water. So how many hydrogen bond between your hydrazine and water? It is 4. Very good. All of you got the answer correct. That means this concept is clear, right? One more question for you all. Give it a try to this particular question as well. The question is the predominant interactions between the phospholipids that stabilizes a biological membrane. Now, this particular question is dependent upon your general knowledge. Put in your general knowledge information over here. Try to mark down the answer via elimination method. Mark down or first eliminate all those options in which is carrying the bonding which is not possible at all in a biological membrane. Just try to correlate with the properties that we have with the help of all the what do we have, the various bonds that we have. Recall the properties and correlate it to the biological membrane. Everyone mark the answer. Take your time, quickly mark the answer. 21 of you are there in the class. Everyone participate and mark the answer for the question. Very good, very good. Nisha, mark the answer. Mansi, mark the answer. Swati, mark the answer. Very good. Excellent. So see over here, you have hydrogen bonds. Like look into the first option. If I look over this particular option, covalent bonding. Is covalent bonding possible in biological membrane at any point? Like is it possible in any point? No. When bondings cannot be there because the covalent bondings are very much strong in nature. They are very much permanent in nature, and in a biological membrane there need to be constant dynamic changes, right? The cell or the membrane specifically need to have constant changes because a number of proteins are entering and exiting the cell. A number of changes are taking place. Some of the phospholipids are flipping to the other side, etc., etc. So covalent bondings can never be there. So A and D can never be the answer. Look into the second and the third one. Second option is van der Waals forces and ionic interaction. Okay, then we have hydrophobic interaction interactions and hydrogen bonding. Now if you remember, yesterday we had a discussion regarding that hydrogen bonding is present in your proteins, right? Hydrogen bonding helps in stabilization of the protein. Now if it is helping in the protein stabilization, for sure it would be helping in other stabilizations as well, right? Answer for this particular question would be option number C itself, that is hydrophobic interactions and hydrogen bonding. Question is asking you about predominant interactions. Okay, out of the four you have to find out most appropriate answer. Remember about this particular thing, that whenever in the CSIR you are given a question, make sure that you are reading the question very very nicely in order, because I'll show you a number of questions, and in those questions you will see majority of the time we'll see that two of the options are correct. But out of the two, which one is more appropriate? That is what we have to find out, right? Because van der Waals forces are still to an extent available, right? But in the question it is asking us about the predominant interactions. So the predominant interactions include your hydrophobic interactions and your hydrogen bonding. Remember about this. Okay, answer is C. Now we have just one small topic for the previous class, that is related to water. Okay, few important features are there which you have to keep in mind for the water topic. That is, it is the most abundant substance of the living cells. 70% of or more content in the cell is of water itself. Then it's a universal solvent. Every single thing can dissolve in your, like it can dissolve every single thing, not all the substances, because oil cannot dissolve in it. Reason being because of its different nature. Then it is odorless, it is tasteless. There is no odor in water, there is no taste in water, right? It is available in solid, liquid, gas form. Then the, if you look into the structure, so it is a tetrahedron molecule with the oxygen in center. Look into the diagram, this is how it looks like. It is a tetrahedron with oxygen being at the center of the molecular structure. Then if you want to remember about the angle, so very very important, remember that the angle between HOH bond, between HO and H bond, it is 104.5. Very important. These type of questions are asked in your DBT examination or ICAR examination. Okay, remember about this, that the bond angle in the HOH, in the water molecule, it is 104.5, which is slightly smaller than the typical tetrahedral angle. Okay, when we look into a typical tetrahedral angle, the angle is by 10, it is 109, but our water have a bit of tilted structure, bit lesser angle than the main tetrahedral. It is 104.5. It is a polar molecule. Reason being, there's a positive charge and there's a negative charge, because oxygen carries a negative charge and hydrogen would be having a slightly positive charge, so we call it a polar molecule. Okay, and then the hydrogen bonding between the water molecule helps in providing the cohesive force. What do you mean by the term cohesive force? So when we look into the structure, or sorry, not structure, but when you look into the water in a glass and try pouring it, try to observe that when the water is falling down, it tend to have a circular, like it falls down in a bubble shape, right? Bubble shape in sense of it starts forming bubbles and then it falls down. Reason for that is it tries, because the molecule of water have cohesive forces in them, which because of which they tend to decrease the surface area, or they tend to decrease their area of contact with any external feature. Like over here in the case example that we are looking, the external feature is what? That is air. So in order to decrease the contact of the water molecule with the air, they tend to occupy the smallest size possible, that is your water, that is your circular bubble. And this circularity or this bubble formation, or we can say the cohesive force between them is what is helping it. The molecules have a cohesive force between them. So, and this cohesive force is provided because of the hydrogen bonding that is there, that makes the water liquid at room temperature and crystalline at lower temperature. Depending upon the change in the temperature, the water changes its property because of the various types of bonds that get formed in between. Okay, one water molecule can form four hydrogen bond, very very important. If you have O, H and H, then you have, from over here two of the hydrogen bonds can be formed, and over here two of the bonds can be formed. So in total four hydrogen bonds can be formed. Then you have polar molecules being hydrophilic. Polar molecules are hydrophilic in nature, that is they are water loving. Okay, then non-polar molecules are hydrophobic, that is they are water hating, because there is no polarity, there is no charge to them, and hence there would be repulsion, they would be trying to stay away from the water, right? Then it is amphoteric in nature. What do you mean by amphoteric? That is like in amino acids also you will get a better understanding. Amphoteric substance means the substance which can occupy or which can work both as an acid and a base. Okay, this is what amphoteric nature is, and this property is known as amphoterism. I repeat, when a substance is able to act as an acid and a base all together, it is called as a amphoteric substance. And if this substance, and if I want to define this property on a whole, so this substance is having the property or showcasing the property of amphoterism. Okay, remember about this. Then water has a higher melting point, boiling point, heat of vaporization, and surface tension. Just keep a note of this particular thing. No one is going to, like in the examination, no one is going to ask you about it, what is the boiling point of water. Okay, so this is something just for your general knowledge. Clear? This was about the main thing, that like two things were remaining, one question and then some properties of water. Now we'll start with our main concept today, that is your amino acids. Okay, is everything clear to everyone till here? Just check. If it is clear, I'll move forward. Right, acids. Okay, now before coming into the topic of amino acids, I'll give you a complete overview regarding and correlate the things of what a amino acid is, what a peptide bond is, what are proteins, what are the various structure of proteins. So sit back and try to focus in the class for the next 10 minutes. Okay, you'll get a very, like this basic understanding will help you understand the next two classes. Okay, so, okay, understand this particular thing. There is something called as amino acids. There is something called as proteins. And one more thing, that is peptide bond. Okay, let's try to understand about each one of them. Now, what are amino acids? Amino acids, like now you have to consider, now consider that you have some beads. Okay, and second thing is I'm making these beads into a very clean linear chain. Okay, this is your amino acids, and these amino acids gets converted into a protein. How? With the help of, with the help of peptide bonds. Okay, when the amino acids join with each other, with the help of a bond in between. This bond is given the name of peptide bond. This is what is known as this formation of a protein. When we look into the protein, the proteins have four of the structures, and these structures are based upon the complexity, and the complexity is dependent upon the type of the bonds present in between. Okay, understand it how. Consider you have the very first one, that is your primary structure. If I'm writing down 1 knot, this is primary. If I'm writing down 2 knot, it is secondary. If 3 knot, tertiary. 4 knot, quaternary. Okay, primary, secondary, tertiary, quaternary. I'm not writing it here because I want to make the slide very clean. Okay, so first we have the primary structure getting converted into secondary structure, secondary getting converted into tertiary, and tertiary getting converted into the quaternary structure. This is of your lowest complexity or least complexity, or I can say the simplest structure is in here. Okay, and this is your most complex structure. Okay, highest complexity. So if I'm going from left hand side towards right hand side, if I'm going from here till here, I am increasing the complexity. Okay, now this increase in the complexity is because of just the type of the bonds that are getting formed. Linear chain is this one, just a normal chain. Secondary structure, this one is your primary structure. In the primary structure I have a linear chain. In the secondary structure I can have alpha helix, I can have beta sheets. Alpha helix are these kind of structure. Beta sheets are that when I am having the protein bonds, or when I am having the linear chains arranged in a parallel or an anti-parallel manner. When then we have tertiary structure, there occurs more increase in the complexity, and the more bonds are getting formed in over here. And in your quaternary structure you have the molecular chaperones. Molecular chaperones include your heat shock proteins or various other types as well. We'll discuss about that also. Between your secondary and your tertiary structure we have something called as super secondary structure. Okay, these super secondary structures includes your motifs and your domains. In your motifs and domains over here, these super secondary structures, like there are the two units of it, that is motif and domains are the two units which need to be defined in a super secondary structure. And in the super secondary structure we have a number of examples. For example, we have Roseman fold. For example, we have beta meanders. For example, we have Greek key. Okay, etc, etc. I'll show you every single thing over here in the subsequent classes. We'll discuss every single thing, but just understand this particular thing now. When we look into the peptide bond, or before that, when I make a structure of an amino acid, the amino acid is consisting of four of the groups attached to it. One of it is the NH3, then you have C, then you have COOH, then you have H, and then you have R. Okay, this is your amino group, this is your carboxyl group, this is hydrogen, and this is your variable group. This change in the variable group is going to change the entire property of the amino acids that are there in our body. The central carbon, this is known as C alpha. Okay, we call it a central carbon. Around this central carbon we have four of the things attached. On one hand you have the carboxyl group, that is COOH. On one hand you have the amino group. On one hand you have hydrogen, and the fourth one is variable group, which is depicted by R, H, X, Y, Z, anything depending on in which book you are reading. They might give you anything, but the basic thing is that this is your variable group. and change in the variable group, whatever is getting attached to your variable group, that is going to change the entire property of your amino acid. Okay, there's an amino acid known with the name of glycine. Glycine is the amino acid which have H over here. For example, okay, it has H over here. The variable group in glycine is H, which makes it a chiral compound. Like we'll be understand, there are a number of properties of amino acids, optical properties I could say, in which we have the property of chirality, achirality, etc., etc. Okay, so we'll be discussing that as well. Before that, this is your amino acid. If I make the same amino acid over here as well, let me draw it on the other slide, you'll get a much clear picture then to understand the peptide bond. So if I have NH3, I have C, I have COOH, then I have R, and then I have H. Okay, I'm making the normal one. In addition to that, I am adding one more amino acid because I have to show the depiction of a peptide bond. So understand this. Same amino acid, like the same structure, all of them have same structure. The difference occurs in your R. Okay, this is the first amino acid, and this one is your second amino acid. How does a peptide bond gets formed in over here? You have OH from the carboxyl group and H from the amino group. There occurs release of water molecule from here, and as a result there is CONH2 being formed over here. I'm not writing down this complete and this complete, imagine it yourself. You have the same structure over here and the same structure over here. Okay, there is release of one water molecule and there is release of one ATP from this entire, in the formation of this entire peptide bond. As a result of release of one water molecule and as a result of usage of one ATP, we have the formation of one peptide bond. Okay, so this is your amino acid, this is your amino acid, these two amino acids join together with each other. As a result of joining together, we have the water release and you have CONH2 getting formed, and in the similar pattern get the entire idea about the further, like imagine there are thousands and thousands of protein amino acids being there. So every amino acid, every two amino acids, like over here as well, if I have NH3, so OH and H will be getting released and you'll be having CONH2 being here, and between this and this you'll be having C, and then you have H, then you have R. Okay, so this is how they keep on getting joined together. Are you understanding this particular reaction? Yes, everyone, are you understanding this particular reaction? Just check. Just go through all these pointers as well, everyone. Go through all these pointers also, and if you find any difficulty, any problem, please ask. Ayush, we'll discuss. I'm not yet done with the protein structure, right? I'm just giving you a brief regarding the same. Yes, Bhargav, you can ask your doubt. Just go through whatever I've explained you till now. If I go into the turns and all those things, then things will become complicated. Okay, I'll go in a very structured manner. Don't worry. We'll discuss in the protein structure, motif, domain, super secondary structure, all the things we are going to discuss. Just go through this basic thing. Just go through this basic framework right now. Okay. Do not go into the depth, because I'll be explaining, like I'll be taking up this topic, I'll be explaining you in detail. Then protein topic in detail, every structure in detail. Don't worry. This is just a framework to keep your mind alert, to give you a flow of information in a very sequential manner. I have given you this complete flow chart kind of a thing prepared. Any other doubt, anyone? Yes, clear. Very good. Let's move forward now. Now, this was a very basic explanation or a very basic framework for you all, but this framework will help you clear out your remaining three classes, in which we are going to discuss amino acids and proteins. Okay, so make sure that you are writing this entire thing in your notebook, and you are like, whenever we now as and when I'll start with amino acid, so you know that amino acid are the basics which or they are the units via which the proteins are formed, so you'll get an idea. Then protein, okay, proteins are formed via amino acids, and in protein I have to cover up all the structure as well, so it's easier. See, look over here. You have the amino acids, you have the proteins. So, amino acids are the building blocks, and then proteins are formed via these amino acids joined to each other with the help of a peptide bond. So, if I look into the general formula, so you have a carboxyl group, you have a amino group, you have H, and you have CH3. This one is an example, which is a variable group or a variable chain. Okay, if I eliminate CH3 and write down R, that is also correct. Okay, so now you have a homework for you all. You have to find out which amino acid have CH3 in the as a variable group. Okay, find it out. Which amino acid have CH3 as a variable group in its structure? Find it out after the class. Okay. If I look into the amino acid, what are these? These are the building block of protein containing C, H, O, and N. Simple. Look into the diagram. C, H, O, and N. These are the only four things. C, H, O, and N. Nothing else. All four of them are there in different combinations. They're composed of amino acids, carboxyl group, H atom, and a distinctive chain that are all of them are attached to a central carbon called as C alpha. They are amphoteric in nature. Amphoteric means that they can act as a acid or a base due to the presence of amino group and a carboxyl group. Now, according to your general understanding, write down which group, like amino group is there and carboxyl group would be there. Amino group would be having positive charge or negative charge if if it is donating the electron. Yes. Yes, positive or negative? Amino group, everyone. Very good. It would be positive. And what about the carboxyl? The second one, carboxyl will be having, it would be having the negative charge. Excellent. Positive would be on the amino, carboxyl will be having negative. That means amino acids are polar or non-polar? Yes. If any amino acid is having both the positive and the negative charge, will it be a polar one or a non-polar one? Yes, it would be polar. Very good, very good. But remember, this is the condition when both of them are having the charge. I'll give you a question. I'll give you the complete list for the entire thing where there are a number of examples of polar, non-polar, aliphatic, aromatic, and all those things. Okay, so I'll show you. Just wait for it. I'll just show you. It exists as a dipole or a Zwitter ion when dissolved in water. Dipole or a Zwitter ion means the same thing. Okay, it's just a different name for that. Approximately 300 amino acids exist in nature, but when we look into the part, or when we look into the amino acids which are participating in the protein synthesis, so they are 20 in nature. Okay, only 20 of the amino acids that are known in nature, they are proteinaceous in nature. Remember about this particular thing. Now look over here, take your time and read all of these quickly. Just a minute for you. Quickly read all the names. Yes, your time to read. I am muted, bache. I know I am muted. Just I am. I have given time to you to just read through these. Just read through these so that those of you who are in the full course, you can just revise it, and those of you who are in the new course, you can just go through the names once. I know I was on mute, and I'm muted just to make you comfortable, and so that you can easily just with concentration read it. Simple, nothing else. Quickly read this, everyone. What is amphoterism? So, amphoteric compounds act as either acid or base. An amphoteric substance has a transferable hydrogen or an atom with a lone pair of electron. Okay, so examples are amino acids, protein, metal oxide, etc. etc. You need not to go into the depth of the chemistry of it, don't worry. Now, talking about the classification. So, the classification is based upon two things. First is essential, non essential, semi essential, and second one, okay, first let's go through this. There are essential amino acids, non essential, and semi essential. Write down what is the meaning of essential amino acids, everyone. Yes. Yes, very good, very good. The name itself would help you out in this. Yes, essential amino acids means those amino acids which are essential to the body and which cannot be synthesized. Okay, that is what essential means. Non essential means because my body can prepare it myself itself, so I need not to intake it in my diets. And semi essential means that is the one that can be synthesized in the body but not during the time when a person is old or when the person is not well. Okay, so essential amino acids, non essential amino acids, and semi essential one. Essential are 10 in number. They cannot be synthesized, they need to be obtained in the diet, and these all are the examples. Then you have non essential, 10 in number. They can easily be synthesized in the body, and these are the examples. Then you have semi essential amino acids. So these are 2 in number. They can be synthesized in the body, but they are not synthesized in a very sufficient amount first, and specifically in the ill people and the children's or very young people like 4 to 5 years of age or maximum 10. Like that's the reason why it is told to have a good diet during when you are not well first, then second specifically to the growing children because their body requires a lot and lot of inputs from the outside to have a better development, to have a better growth, right? So they specifically in the ill children and people, ill people and children. Okay, so these are the examples. Quickly go through this. Any doubt, any problem, ask me. Done. Nisha, I didn't understand your question. Arginine is both. It is not. Okay, it is present. I don't know these plus and nt. Please write down full letters. I am a very bad person in this. I have no knowledge about these short forms. Okay. Arginine is present in both and semi-essential. Yes, very obviously it would be present in the essential and the semi-essential one because it is required in some less amount, right? And there's a specific condition to it, so we can consider it as a essential amino acid as well. Bhargav, you can write down your doubt as in when you have doubt and you're given time for that particular thing, you can ask. Dipole means when you have a positive and a negative, and that is what a dipole is. Positive, negative. Zwitter ion is the same. We have discussed that. Dipole. Di is two. Pole means positive and negative together. Clear? Let's move forward now. Now we have one question, that is why is a peptide bond covalent in nature? Okay. Question is why peptide bonds are covalent in nature. There is no trick, you just have to remember it that way. There is no way to like remember, because some things like you can make your own mnemonics. Actually, I didn't make any mnemonics for that particular thing, so I have no mnemonics formed till now. I'll try if I can make, but at present I don't have it. Okay, so why is a peptide bond covalent in nature? The answer for this is over here. Understand this. It's a covalent bond because there is equal sharing of electron. Very, very important. This can be asked in DBT. This can be asked in CSIR as a statement wise question. So remember about this particular thing. Okay, so it's a covalent bond because there is very much equal sharing of the electron that occurs in order to form the bond, right? And this type of bond occurs between the amino acids and connect them together. Okay, specifically the bond occurs between the amino group of one and the carboxyl group of the other one. Okay, remember this. Why peptide bond is polar in covalent in nature? Because there is equal sharing of electrons getting done. And why is it a non-polar? Like, why is peptide bond non-polar? Because the polar covalent bond is a covalent bond in which the equal number of in which the atoms have a unequal attraction, so the sharing is unequal. See, do not get confused over here. Peptide bond is covalent in nature, but it is non-polar in nature because equal sharing of electron is there, but the attraction is not equal because of the resonance in there. When we look into the molecular structure of amino acids, like if you have a amino, like when you look into the peptide bonds structure, we have the bond getting formed and there is jumping of the electron at a specific point. Like when the peptide bond is formed, the jumping of the electron is there at one point or the other, and because of the jumping of electrons, initially the electrons sharing is equal, but there is unequal attraction of the electrons in here. So that's the reason why, even if the sharing is equal, but because of unequal attraction, we have the no, peptide bond being non-polar in nature. Because sometimes you'll see positive and negative to this particular end, on other sides you might see positive and negative to this, on some points you might see positive and positive, and on some points you might see negative and negative. So that's why on a molecular basis, on the molecular level, we call the peptide bond as covalent but not as a polar molecule. Okay, peptide bond covalent, it is covalent in nature but it is non-polar. Reason being, the electrons that are shared, they are shared equal, but the unequal sharing makes the sharing unequal on molecular level. Do not get confused. Okay, so it is a non-polar covalent bond because it holds the two amino acids together. Okay, so remember that on the molecular level sharing is unequal. That's the reason why we call it a non-polar covalent bond. Okay, remember about this particular thing. And if it like, take your time, read this. If you find any difficulty, you can ask. Do not get confused that why we are calling it on one hand as a covalent one and on one hand as a non-polar one. Okay, quickly go through this, everyone. Ayush, you uh, answer this yourself first. Answer this yourself first. Bhargav, at least read it again. Like, try to keep your mind active. Explain, I'll explain again, but at least give it a try from your end first. Read it, everyone. When you're given time to read, you have to like pause and read it first before asking it again. You have to read it first. That's why I give you all time to read in the class itself, so that you can clear out your doubts then and there. Yes, Ayush, covalent bonds have dipole moment, but point over here is we are discussing about a specific type of covalent bond, which is a like a specific example of covalent bond. Shivangi, it's not about the amino acid forming a bond. It's about the peptide bond. It's we are talking about the nature of the peptide bond. Okay, the peptide bond is a covalent non-polar bond. Don't get confused. Okay. Any other doubt, anyone? Very good. Okay. The next thing, this is which we are going to discuss in unit number 3 specifically. Okay, now there are few pointers which you have to keep in mind for amino acids. First one is that the acids exist in two forms, L form and D form. What is L form, what is D form? I'll explain it to you. Remember that the amino acid exists in levodextry and levorotatory and dextrorotatory form. What is the meaning of this? I'll show it to you. Then amino acid uses the synthesis of the proteins on the ribosomes, which is always a L amino acid. Okay, that is when we'll study about unit number 3, that is the central dogma in biology. Over that we'll see that the translation process, like if you look in there, you have DNA getting converted into RNA, getting converted into proteins. So in the conversion of RNA into the proteins, we have the usage of ribosomes in here. RNA is decoded, it is translated into the proteins with the help of the ribosomes, and we have tRNA, all the other things in there. So over there, the different amino acids are brought in with the help of tRNA. So the property or the type of the amino acids that are brought in, they are always L form. Okay, then microorganisms uses D form amino acids or the D amino acids for the cell wall synthesis. This could be a potential statement in your ICAR. Then average amino acid contains 450 average proteins. Like average protein structure contains approximately 450 amino acids. Okay, if you look into the longest peptide which is there in nature, it is 30,000, made up of 30,000 amino acids, which is known as TITIN. It is a muscle protein, and in this a peptide is found which is made up of 30,000 amino acids. Okay, then the amino acids, after incorporating in the peptide chain, they are called as residues. Very very important line. Amino acids, like if I'm calling or if I'm looking into the beads individually like this way, this is what amino acid is. But when this amino acids join to each other to form the peptide bond, now we'll be calling it as a what we'll be calling them as residues, amino acid residues. Okay, this could be like, students can get confused if any experimental questions are asked. You can observe over there, after it is getting converted into a amino acid, like after it is getting bonded together, they are called as residues in the questions also. Okay, remember about this. Then they can also have side chains attached. Okay, for example, in the carbohydrates, glycoprotein, like if a carbohydrate is attached to the protein, we call it as the glycoprotein. If a metal is attached, we call it a metalloprotein. If any organic group is attached, we call it a flavoprotein. Okay, remember about this particular thing as well. Okay, very important pointers. DBT examination, potential pointers can be taken up. ICAR potential pointers can be taken up. In addition, in CSIR also, in part C specifically, statement wise question, you can get questions or pointers can be picked up from here. Okay, now we have a number of properties of the amino acids. There's something called as polar, non-polar, acidic, basic, hydrophobic, hydrophilic. Let me ask you all the properties first. Write down what is acidic and write down what is basic. If any particular amino acid or if any particular substance in general is working as an acidic amino acid, what is the main property, or what is the main highlighted feature shown by it? Think about it, everyone, and write it down in the chat section. Acidic, basic, then we have uh, what else? Polar, non-polar, hydrophobic, hydrophilic. Okay, write down about acidic and basic first quickly. You just have to correlate whatever we have discussed till now. Think about it, everyone. Acidic is the one which donates proton. Okay, okay. What else? Just write down about acidic and basic in a single answer, because I have to check how many of you are writing it down. I can keep a track of that as well. Very good, very good. So stands that is donating a proton. Okay, basic is the one which is accepting a proton. Remember about this, because students get confused in this acidic and basic thing as well. Then we have polar and non-polar. So polar is the molecule having positive charge and or the negative charge. Positive and negative, if it is there, we call it a polar molecule. Non-polar is the one which is not having any charge, or in some conditions having very very less charge as well. Non-polar molecule with less or no charge, example is oil. And what is the result of a polar and a non-polar combining together? Write down in the chat section, everyone. If a polar and a non-polar molecule join together, uh, mix together, then what is the result for that? Think about it. Yes, think about it. What will happen if acid and a base join together? What will happen? Oh, sorry, when a polar and a non-polar is mixed together. Very good, Shweta. Very good. Yesterday, I gave you a term for that. A specific term for that was given to you. Think about it. What was it? Some of you have written down also. They cannot mix together, and they both will be repelling each other, right? They both would be having a repulsion between the two. Then we have something called hydrophobic and hydrophilic. Hydrophobic means something that repels water. Hydrophilic is something that loves water and try to add it on there, right? So if it is hydrophobic would be non-polar. Reason being, water is polar in nature, and if it is have to, or it if it want to repel water, it should be a non-polar molecule. So hydrophobics are non-polar in nature, and hydrophilics are polar in nature, right? Remember about this particular thing as well. Now you have, let me show you one diagram first. Yeah, look over here. We have the classification of the amino acids based upon the property of their R group or R chain. Now, if you remember in the very beginning of the class, I told you that it is the R group, or it is the variable group onto which the property of our complete amino acid is dependent upon, right? So over here you have polar, non-polar, hydrophobic, aliphatic. I'll show it to you. What is it? Aliphatic R chain and or aliphatic R group is present. These all are the examples. Non-polar aromatic R group is present. These are the examples. Polar uncharged R group, example. Polar basic positively charged R group, example. Then polar acidic negatively charged and hydrophilic amino acids. These are the examples. I will suggest you that you should keep a note of these in your mind, but don't try to waste a lot and lot of your time onto just mugging it up. Okay, if you revise it 10 to 15 times before your examination, it will automatically get settled in your mind. Okay, so what I did during my preparation time for solving out anything which I was not able to remember on a go, I used to write it down on a sheet of paper and paste it in front of my wall. Okay, I had my study table, my study room. In that, wherever, like, because study table is the area which on which we spend the maximum number of time of our preparation. So try making your, like, the front of your study table very much interactive in sense of try writing down all the things possible over there which you think that it might skip off your mind. Like, I had written down, if I have the picture, I'll share it with you all as well. I had written down all the amino acids with their 3-letter code and a 1-letter code. I had written down the like all the Drosophila genes as well. Like, because these things are something which we tend to like forget while we are preparing, while we are actually like doing the thing or in the preparation phase, we tend to forget these rote memorization things. So it's good that you write it down on a sheet of paper and paste it in front of your wall. It would help you remember things better. Okay, so don't worry that these are very very long list. This is just the second class. You are going to have 100 plus classes in the batch, so it would be a lot and lot of content. Go in a systematic manner, go in a very sequential manner, and you won't face a problem. Those of you, like, because many students are going to join in the middle, but if you are there in the batch since the beginning, use the classes from beginning and try to be very much regular in your preparation. Okay, so this is about the classification of the amino acids on the basis of the polarity. There's a term called aliphatic, there's a term called aromatic. I'll show you, or in tomorrow's class we'll discuss the complete all the properties, like all of these properties of the amino acids, like polar side chain, polar uncharged if it is there. So I have written down the names on a complete different slide, and over here you have the molecular structure as well, with complete name, 3-letter code and a 1-letter code. Okay, so you have to keep a note of all of these things. Amino acids, if asked in the examination, it's a scoring topic. Reason being, it's simple, it's very basic, and you won't face much of the difficulty in uh, covering it up. Okay, so just quickly go through this. Tomorrow we'll have discussions further. If you find any difficulty, you can ask in here. Okay. Just check if it is clear till here. Clear every. Tyrosine must be having two of the things. Then tomorrow we'll have a better discussion. Don't worry. Tyrosine must be having two of the different properties shown. Don't worry. Tomorrow we'll have a better discussion. Like in detail, we'll discuss about all of this. Then we'll have a. You'll get the understanding. Okay. In the evening also I'll have a class. So in the evening we'll discuss all these things. Okay. I'll let you know the timing. I have to visit the doctor again. So I'll be back by 5:30. So after that, I'll keep the class. Okay. So good luck, everyone. Take care. Let's meet in the evening. I'll send you the class timing. And those of you who have a class at 11:45, freshen up. Be there in the class at 11:45 now. Okay. Bye, everyone. Take care. Let's meet in the evening now. Okay. Bye, everyone. Take care. Welcome, welcome everyone. Welcome. Bye.